Hey everyone. So you are about to see Mr. Lambert go into full-on geek mode because we are getting ready to talk about what I think is one of the most interesting parts of modern science, and that is what we know about the universe. In particular, this week we're going to start talking about galaxies. Now, before we get into talking about galaxies and in particular what are the fates of galaxies as they go through their life cycle today, I wanted to give us some scale because we've been learning about our planet. We've been learning about our moon, the solar system. So I wanted to give us some scale in relationship to those things as to what we're talking about when we talk about a galaxy. So this is us. This is the planet Earth. This is actually an image from space, probably taken from the International Space Station or a satellite. You can see the curve of the Earth there, and that outline that you see, that's actually North America. And that little arrow that's pointing down to that tiny little dot, that is where you are. The slightly brighter dot down below it would be Indianapolis, and we are just above there. So that is where we are on this planet. If we think a little bit further out, here's what that planet looks like from the moon. Now, this was the first time, this is actually a very famous image taken from the first lunar landing, the first time that men walked on the moon, taking a picture back at the Earth. It's called the Earthrise, kind of like we have sunrise or moonrise. This is the Earthrise from the moon. Now, that little ball over there, up until this point in the 1960s, was the only thing that humans had ever been on. This was the first time that humans had actually left the orbit of the Earth and gotten anywhere else. Actually, case in point, no one's ever been farther than these guys went. A handful of people, less than 24, have actually made it out to even orbit the moon. Even less than that have walked on its surface. This is still kind of as far out as man has ever gone, at least in person. But we know more. When you think about scale, so that entire ball that we've lived on for forever, all of humankind, all of human civilization and history, has been on that tiny little blue dot. Here's what it looks like in relationship to our sun and our biggest planet in our solar system, Jupiter. So there's Jupiter. Earth can fit around 30 some Earths across the diameter of Jupiter. That means across its middle. But if you were to take the Earth, you could fit 109 of them across the center of the sun. But if you were to open the sun up like a giant round ball and start dropping little Earth-sized marbles in it, you could actually fit over 1 million, 1.3 million Earths inside the shape of that sun. To give give a little more perspective, remember 99.8% of all the mass, so all the stuff in our solar system, is compressed and contained in that sun. The remaining 0.2% make up all of our planets, moons, asteroids, and comets. So, our sun is not the only star. This is an image from the night sky looking out from Earth. And if you see that tiny little red dot right around, here, it's blown up into here, that tiny little red dot is our nearest star neighbor. That is a little red dwarf star called Proxima Centauri. That is our closest neighbor, and look how tiny it looks from all the way over there. The sun wouldn't look much different to someone orbiting Proxima Centauri as Proxima Centauri looks to us. Maybe a little bit brighter, but not much different. That is our closest solar neighbor. Another way to look at it, here's our sun, here's the Oort cloud that orbits our sun. Now, this is not to scale. Our sun would be a tiny dot right in the middle. Just to give you some perspective, the farthest we have ever sent anything out into space are the Voyager probes. Voyager 1 has just now entered the edge of the Oort cloud, and it will take it about another 30,000 years to make it to the end of that Oort cloud, around 1 light year away from the Earth. 2 light years away from the Earth, this would be about as far as that Oort cloud goes out, and then a little over 4 light years away is Proxima Centauri. So just to think, remember, it's going to take about 30,000 years to get through this sky right here. Proxima Centauri is over twice as far. That's our closest solar neighbor. Its closest two neighbors are in a orbital system around each other. So it's Proxima Centauri, Alpha Centauri A, and Alpha Centauri B. So those are our closest star neighbors. Moving on. Here's where we are in relationship to the rest of our galaxy. So here's a galaxy. The Sun, Proxima Centauri, all of its neighbors, they're all in this tiny little region right here. This is where you are, about 26,000 light years away from the black hole at the center of the Milky Way galaxy. That's right, there's a giant black hole in here called Sagittarius A star. It's not just a regular black hole, it's what we call a supermassive black hole. It's actually so massive and so big, it's eaten up billions of times the mass of our sun. And it has such a huge amount of gravity that it actually causes the rest of the galaxy to spiral around it. So this is where we are. Don't worry, you're not going to get sucked in because you're 26,000 light years away from that central space. In this galaxy alone, in our Milky Way galaxy, there are 200 to 400 billion stars with at least 100 billion planets. 500 million of those, which may have all of the elements that we understand that could support life. So like water, liquid water, oxygen, carbon, those types of things. Just as in perspective, our Milky Way galaxy is about 13.2 billion years old. Just to give you an idea, scientists believe our entire universe itself is around a little over 14 billion years old. So our Milky Way galaxy formed, well, not too long after the formation of our universe itself. Our Milky Way is moving at a rate of 552 to 630 kilometers per second. That's not per hour, that's per second. Being pushed away from what's called the local void at 600,000 miles per hour. Our solar system travels at 447,000 miles per hour and takes around 250 million years to complete one galactic rotation. So to put that in perspective, our little sun is going to keep moving around in its little spiral arm here. It's going to take it 250 million years to make it all the way around. And as we look out from our galaxy, this is actually the deepest picture that we've ever photographed. This is what was called the Hubble Deep Field Photograph. This was taken in the 1990s when the Hubble Space Telescope was sent up. Now, this is as far as we have seen into the universe. So this is, look at all those billions and billions and billions of stars, right? This is the farthest we've ever seen. But if we take this image and actually break it down and look a little bit closer, we find out that those are not stars. Those are actually galaxies. We're talking billions and billions and billions and billions of galaxies. And this is just one small part of the night sky. This is actually an image blown up from that other image. These are actual galaxies that we can see. If we go out even further, well, those galaxies, because of gravity and what we call dark matter, so gravity pulls things together, dark matter pushes things apart. Because of those two different forces, the gravity between galaxies pulls them into what we call strands. So we have a local group of galaxy, and that local group of galaxies is right about here on our strand. These things are called strands or filaments, and they are groups of galaxies that are pulled together by gravity as dark matter pushes voids apart in between them. Those galaxies connect together because of gravity into other parts of the strands and filaments that make up our universe. And if we look out as far as we can see and as far as we can compute, this is what we believe the universe looks like in total. So all of those strands and filaments, they all connect together with giant voids in between, creating what we know as our universe. So this is the universe at its biggest level. But what about our little galaxy? So how does it compare to its neighbors, and what will happen to our cosmic neighborhood in the future? I want you to read on for today. Read the section below and watch the videos to see kind of what's going to happen. How does our little Milky Way galaxy Uh, how do we measure up against our cosmic neighbors, and what's going to happen to our cosmic neighborhood as it goes through its life cycle as a galaxy. Hope you guys find it as interesting as I do. Go ahead on and read below.